Today we'd like to look at the electron dot diagram. What is it and why would we use it? First of all, if you look at barium, barium is number 56 on the periodic table. Barium has 6 energy levels or rings, and I have it listed there at the top here. The first ring will hold 2, the next one will hold 8, 18, 18 for the fourth ring, 8 for the fifth, and 2 for the last or sixth ring. And that's quite a lot of electrons in this Bohr model that we see here. So again, barium is in column 2, so I have the red 2 at the top. That tells you that the outermost energy level has 2 electrons in it. And the 56 in this case tells you how many total electrons. This is an awful lot to draw. And what's really interesting about barium is all those other 54 electrons within the first 5 rings have nothing to do with how barium would bond with something else. It's really only the outside ring that we really are worried about here. So what if we made an electron dot diagram? Well, in this picture, to the bottom left-hand corner, I have made the electron dot diagram for barium. You start out by taking the element symbol, which on the periodic table is Ba, and then you write that, and then you put around it X's to represent the electrons that are in the outermost ring. In this case, there's 1 at the top and 1 to the right, for a total of 2. A lot less confusing than looking at 56 and a lot less to draw. So let's do another example here. I have the periodic table up to the right, and if you notice at the top of each column, we've done this already, I have labeled these column 1, column 2, skip the transition metals, column 3, 4, 5, 6, 7, and 8. And this tells you how many electrons are in the outermost ring of each of those atoms and elements. So every one of those in column 1 has 1 electron in the outermost, column 2 has 2 in the outermost ring, and so on. So oxygen, if we look for oxygen, oxygen is located in column number 6 right here. That tells you that there are 6 electrons in the outermost ring of oxygen. We also know, so the symbol for oxygen is a capital O, so we put that right here in the middle, in this middle box, capital O. Now you have to place those 6 electrons around the outside of that symbol. And you always start like hands on a clock. You start at 12 o'clock first, and then 3 o'clock, and then you go to 6 o'clock, 9 o'clock, and then you start back over at 12 again. So let's start by putting the first one at 12 o'clock, first X. The second one will go at 3. The third one will go at 6. And the fourth one will go at 9. Now again, this has a total of 6 electrons, so we have to go back up to 12 again and repeat. There's number 5 and number 6. So right here we have created the electron dot diagram for oxygen. Now what is the purpose of all this? The purpose of this is to help you bond later on. When elements bond together, such as hydrogen and oxygen, it only matters what's in the outside ring. Hydrogen has 1 in the outside ring in column 1, and oxygen has 6. And I think you've probably heard of something called H2O, where we have to take 2 hydrogens and bond it with the 6 oxygens, because when you do that, the outside ring either wants to have 0 or 8 in it. It's called the octet rule. And in this case, if hydrogen, each of those 2 hydrogens shares with the oxygen, then that outside ring of oxygen will have 8, which we would call H2O, or in other words, water.